This lesson is on estimating square roots that are not perfect squares. First, we're going to look at this top section and get kind of a warm-up for our brains. Jennifer is purchasing a square canvas for a custom artwork piece she will create. She wants the canvas to have a side length that is between 8 and 9 inches. She finds a canvas with the area shown at the right. Estimate the dimensions of the canvas and explain your thinking. Does the canvas meet Jennifer's requirements? So I want you to think about how we find the area of a square and take a second to pause the video and just think what you think the dimension of the canvas might be and whether or not it meets Jennifer's requirements. So let's look at this together. I know that the area of a square is found by A equals S squared. So Jennifer wants her canvas to have a side length that is between 8 and 9 inches. So if she has a side length of 8, then area would equal 64, because 8 squared is 64. If she has a side length of 9, she'll have an area of 81. So I know that if the side length is going to be somewhere between 8 and 9, the area would be somewhere between 64 and 81. This canvas is 90 square inches, so this does not meet her requirements. It is not, 90 is not between 64 and 81. Let's see what side length might work. If I have a side length of 10, that would give me an area of 100 inches squared. So this canvas, the side length is going to be somewhere between 9 and 10. And 90 is almost right in between 81 and 100. So my guess would be that the side length of the canvas is going to be somewhere around 9.5. So the area of the canvas above represents a non-perfect or imperfect square. And we're going to use our knowledge of perfect squares to estimate the square roots of non-perfect or imperfect squares. So we know from previous lessons that perfect squares are numbers whose square roots are whole numbers. And some examples might be 64, 4, 196, because the square root of 64 is 8. The square root of 4 is 2. The square root of 196 is 14. Those are whole numbers. Non-perfect squares are numbers whose square roots are not whole numbers. So they'll be irrational numbers, like the square root of 6, for example, is not a whole number. The square root of 45 is not a whole number, or 180. There's no whole number that I can multiply by itself to achieve the number 6, or the number 45, or the number 180. What we're going to do is we're going to use our knowledge of the square roots of the perfect squares to estimate where we think the square root of a non-perfect square might be. We're going to start out by using number lines to help us with this. Something that might help you is to list out your perfect squares and their square roots like I've done above in green. This is essentially a number line, and I've just listed the whole numbers and their squares, or the square roots, the squares, and their square roots. So if I'm trying to estimate the value of the square root of 50, I know that 50 is a non-perfect square because there's no whole number I can multiply by itself to get 50. The first thing I'm going to do is use the number line to locate the whole numbers that the square root of 50 should be in between. So the square root of 50 is going to fall somewhere between the square root of 49 and the square root of 64. And I know that the square root of 49 is 7 and the square root of 64 is 8. Then I'm going to decide which whole number the square root will be closer to. And I'm actually going to use the perfect squares to do this. So is the number 50 closer to the number 49 or to the number 64? Well, it's way closer to the number 49 than it is to 64. So 50 is closer to 49. So this means that the square root of 50 will be closer to the square root of 49, which is 7. So I know that the square root of 50 is going to fall somewhere between, realistically, 7 and 7.5. Now the numbers I have between are going to be 7.1, 7.2, 7.3, 7.4, 7.5. Given how close 50 is to 49, I'm going to start on the lower end of that. So I might start with 7.2. And what I'm going to do is I'm going to multiply 7.2 times 7.2, or I'm going to square it. Well, this number is going to be pretty far away from 50. So that's a little higher than 50. So I'm going to go a little lower and do 7.1 and square that instead. So 50.41 is the closest I got to 50. So 7.1 is the best estimate for the square root of 50. Let's look at a couple more examples to make sure I've got this down pat. Estimate the value of the square root of 22. So the first thing I need to do is find out where 22 fits on my perfect square number line. I know that 4 times 4 is 16, and 5 times 5 is 25. So those are the perfect squares it's going to be between, which means the whole numbers will be 4 and 5. Now to decide which one it's going to be closer to, I need to think, is 22 closer to 25 or to 26, and by how much? Well, 22 is 6 away from 16, but it's only 3 away from 5. So my guess is that it's going to be closer to 25, which means it's going to be closer to 5. So the options we have between 4.5 and 5 are 4.5, 4.6, 4.7, 4.8, and 4.9. The reason we want to go between 4.5 and 5 is because anything less than 4.5 is actually closer to 4 than it is to 5. And we already decided that our answer needs to be closer to 5. So I'm going to start with 4.6. And I'm going to square it or multiply it by itself, just like I did before. 6 times 6 is 36. 24, 27, my 0, 24, 18. So that took me to 21.16. That is pretty close to 22, but it's still under. So I'm going to try the next one, which would be 4.7. 7 times 7 is 49. That's 28 plus 4 is 32. 28, 18. So 22.09 is real close. So I need to decide which of these is closer to 22. Well, this is 0.09 above 22, and this is going to be 0.84 below it. So what's closer is 22.09, which means that the square root of 22 is closer to the number 4.7. So in that first step, when we're deciding what whole numbers it's between, it's kind of like going to the grocery store and saying, okay, what department is it in? Then when we find out what it's closer to, it's kind of like saying, okay, what aisle is it on? And then when we get down to deciding what we think the square root is closest to if we're rounding to the nearest tenth and coming up with an actual number, that's like saying what shelf is it on. So each time we're getting more specific. So we're going from the department to the aisle to the specific shelf that it's on. Another way to think of that is that the first step is saying, okay, my friend lives in this neighborhood. The next step would be, okay, what street does he live on? The next step would be, what's the house number? So we're getting closer and closer to the specific location as we move down the steps. Let's look at another example. Estimating the square root of 103. Well, I know if I'm going to find the department or the neighborhood, the first thing I need to do is find the perfect squares on either side of 103. I know that 100 is a perfect square that's lower than 103, and there's nothing between them. And the square root of that is 10. The next number would be 11, and 11 squared is 121. So the square root of 103 is going to be somewhere between the square root of 100 and the square root of 121, or 10 and 11. Now, 103 is way closer to 100 than it is to 121. So I know that it's going to be closer to 10, which means we're going to be using the numbers between 10.1 and 10.5 for our estimate. I'm going to start with 10.2, and I'm going to square it. So I've got 4, 0, and 2. Bring my placeholder down. 2 placeholders. And I end up with 104.04. That's relatively close to 103, but it's a little over. So instead of trying the next one up, I'm going to try the next one down. Placeholder, 2 placeholders, and this gives me 102.01. So I need to decide how far they are from 103, and I can do that by subtracting. So if I have 104.04 and I take away 103, I've got 1.04 left. If I need 103 and I have 102.01, I need 0.99 more. Well, this gets me closer to that 103 that I need. So I'm going to go with 10.1. So the square root of 103 is approximately 10.1. So I found the department or the neighborhood. I found the aisle or the street name, and I found the shelf or the home address.